Hi all, I'm Jaydeep Bomidi. I'm here to present my final project on ADTF 5550 subject Deep Learning. This project is about working on CIFAR dataset, CIFAR 10 dataset, and this CIFAR 10 dataset consists of 60,000 color images and they're of size 32 by 32, and the project is to develop a convolutional neural network so that we can classify the CFAR images properly. So let us go into the overview and understand what are we going through. So the first is about the dataset. We'll talk about the CFAR dataset, and then followed by it we will talk about the model, the convolutional neural network model which we have developed. And then I will train and test the model, and I will try to check the accuracy of the model on the test dataset. Then I'm going to talk about the model performance, where I will be comparing the model performance on MNIST and the CIFAR 10 dataset, and we will try to draw some uh, deep insights from it and try to understand the complexity of deep learning when applied to image processing problem statements. And then later I will try to improvise the model, and once the model is improvised, the main goal of improvising the model is to build and understand the complexities of trying to work with CNN, which are convolutional neural networks. With that, we will have an understanding about the various procedures, processes, and approaches that can be done through convolutional neural networks. And then I would like to give a conclusion of the project and the aspects and the insights which we learned and which we can take home and work on for the real world problem statements when we are posed with a problem statement by a company or by any question for that matter. Now, I would like to talk about the dataset. Now, in this dataset, particularly, um, it's a subset of a bigger set, and hence it is called CIFAR 10, and it only consists of 60,000 32 by 32 color images, and as you can see on the side there are three sample images for your view and understanding. And you can see that since we are using only 32 pixel, and each pixel is generally in the form of a square, and you can see here that square cubes very clearly visible because we are trying to define a very high featured images with just 32 pixels, which is really tough to do with articulation. Now, there are 50,000 training images in this dataset and 10,000 test images in this dataset. The dataset is divided into 5 training batches, and we will see in the code as to how the dataset is divided into 5 training batches and 1 test batch. Now, each batch consists of 10,000 images. Now, why is it that the 5 test batches are created? It's because the test batch generally contains 100 randomly selected images from each class, and the training batches containing the remaining images in a random order. So, um, now I would like to tell about the classes. For example, there is no need to worry about the classes getting clashed because they are mutually exclusive. That means there is no overlap between the classes like the automobiles and the trucks. So, um, for example, I take an automobile like a sedan or SUVs. These cars are generally the cars which we will drive. And if we take trucks, we only include the big trucks. We don't include any pickup trucks like the small trucks. So we have a clear understanding about this dataset. Now, the 10 random classes or the 10 classes which we are currently working on are aeroplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. These are the 10 classes which we will be working on. Now, there are multiple deep learning algorithms like ResNet. ResNet is one of the popular dataset which is present. No, which is one of the popular convolutional neural network which gives a very good results, and ResNet works really good on CFAR dataset. Now we are just working with very basic um, neural networks in our situation or in our project, because we will not be using GPU based computations, so hence to reduce the computation time and proceed with an understanding and learning objective of convolutional neural networks, we only go with the base neural networks which have one or two layers or three layers at max. So, which helps us to understand the concepts. Hence, this is the dataset which we are working on. And now, I would like to talk about the model. So, when I speak after about the model, I will go back to the code and I will talk about the code and the different functions which we defined in order to build the convolutional neural network so that we'll gain an understanding. Now here, as you can see, this is the model which I have developed to work on CFAR 10 dataset, and this model which you are seeing here is a convolutional neural network. So in general, a convolutional neural network consists of different layers which are of different types. One is convolution layer, the other is pooling and fully connected layer, and so on. Now, inside each and every convolution layer, we have neurons. So we need to have some activation functions which are the basics of the deep learning architectures. Hence, we are putting ReLU activation functions in it, and then followed by each neural network or convolution layer, I will put a max pooling layer so that to, to keep in check that the size of the neural network is not exploded. And max pooling is mainly to reduce the size of each and every layer. I mean, after every computation by the convolution, the size increases, and then we reduce the size by using max pooling. And then in the output layer, we use softmax cross entropy loss function. Because we are using one hot encoding where we are taking the 10 classes, we are performing one hot encoding because they are categorical variables, and after performing performing one hot encoding, we can use the softmax cross entropy loss function. Okay, now I would like to go to the code so that we'll have an understanding about what we are working on. And here I would like to show you that this is ADT, it's on ADTA subject 5550, and as you can see the first line is about where our dataset is stored, and then we have defined a pickle function, unpickle function, and as you can see that we have 5 batches of data batch 1, data batch 2, data batch 3, 4, 5, and test data. So these are the 5 batches which conclude or which comprise of the training data. And now we do that, and we get all the data inside uh, all data such that we can access this data later on. Now as you can know, in MNIST dataset, it is a very good and well programmed dataset that we can read and write through the given libraries, but we need to create our own library to access them. Hence, we'll be creating a class and we will be discussing about that. Before going further, I would like to show you some simple images of this dataset. So as you can see here, this is an image, and this is an image of a truck, and this is an image of a car. So these are the sample images with very low resolution of 32 by 32 pixels. Now we are performing one hot encoding because we are using 10 labels which are the classes, and each class will have